Okay, this is the code walkthrough of the credit worthiness dataset. It's phrased as a business problem. We have 250 new loan applications. We want to speed up that processing, and we have a data set of 500 records from which we can build a model. So there is a PowerPoint presentation which should be part of this playlist that is a lot less technical, and in a nutshell kind of summarizes this particular code walkthrough. So let's look at the middle of the screen is the outline. As expected, the typical import, clean, and then we model in the training set, then the test set. We pick a model and we predict on our new 250 loan applications. Okay, starting at the top, pre-processing recommendation reference for our various models. We load our libraries. And here is the two data sets: credit data training, 500 records; customers to score, 250 records. The data is fairly clean. There are some things that need to be done, but those can be done during pre-processing in each of the models. But we do want to quickly let me just quickly glimpse and look at the data so that you have an idea what it looks like. So let's glimpse here and skim. So this is the credit data training, 500 records, and we only have 20 columns, 20 variables, or 20 fields. Here is our outcome, credit application results. It's binary, one of two. It still has a character, but when we get done, a lot of this is going to be as factors. Some of it is expected numbers, such as credit amount. All right, there's an actual dollar figure, but then others are coded as perhaps here duration and current address is coded, or perhaps most valuable asset is coded, because there's a ones, there's twos, there's threes and fours. So, and then near the bottom clearly looks like some kind of coding going on as well. Our glimpse gives us our skim gives us our data summary grouped by variables as character and numeric. Okay, so obviously we got to clean up some of this, and let's see here. I think when we get done, it's going to look like this. Do we have any? No, not yet. Okay, that's not important, because again the data is fairly clean, so we're just going to move on. We've also looked at correlation table. There's nothing special going on here, but if there was, we could just do the decorrelation in the pre-processing steps. Let's just move on to the more interesting things. Here we're going to spend our data, and if we look at the data, we can quickly see that, let me see, an initialized column, credit data train. What's going on here? Okay, we're back. I had done some previous work and reloaded some things, so some of the variables got messed up. So when we look at our table, we see that we actually have unbalanced data. Creditworthy 358, non-creditworthy 142. So when we do our next slide, we set our seed, and then we split our data into training and testing. So we do 70% on train, 30% on test, and we set the strata. We have to set the strata because, again, imbalanced data. When we look at strictly credit split, then we can see how our data has been split. 349 for training, 151 for testing. Okay, just a simple function to plot our ROC curve. Let's get right into models. And here we do the cross validation. We set it to 10 on our credit split, which was previously split 70-30. And let's get into train. I'm just gonna go somewhat deep into logistic regression, but not do it for random forest and support vector machine. Okay, so logistic model here, we're using the Tidymodels framework. So we're defining a model, recipe, a workflow, and now we're going to tune it. On a logistic model, we are going to tune a penalty and mixture, set the engine and the mode. And I may have forgotten to mention this previously. This is a classification problem, right? With picking credit-worthy or credit or non-credit-worthy. It's two-class classification. We're also going to tune our grid. Or we're going to tune using a logistic grid, set it at 5 levels. So when we look at the grid, we see it is 25 rows. And what's nice is that this particular function, grid regular, is going to pick numbers that should work with modeling this particular set of, or this particular model setup. We're going to put it into recipe, and here's how we're going to do the pre-processing. We're going to impute median age. We're going to remove this field. Zero variance on all predictors, which pretty much means if there's anything unique in a particular field, just get rid of it. And then we're going to step dummy all nominal predictors. Put it into a workflow, and then we're actually going to tune it, right, and resample it at 10-fold cross validation. Then we're gonna check the tuning. We can kind of see what the plot looks like, and then we see it here, the result of our tuning with all those different parameters. We're gonna select the best model, and tuning has determined that the best model is penalty 1, mixture 05, or model number 5. Out of the 25 that were created here, at least combination of parameters. So 25 models were tested, and model 5 was deemed the best result based on the parameter or metric of ROC AUC. Okay, and now we're going to do some massaging of the data to get it looking nice, so that we can end up with a ROC curve that looks like this, right? Logistic regression, training, AUC, and an accuracy metric. Okay, and then we do the same for random forest and support vector. Random forests, of course, are a bit different. We set the mtry, trees, and min-n to tune. Well, actually, mtry is set to the square root of the number of columns, which, by the textbook, kind of says that the square root of the number of columns is a really good starting point. So there's no need to tune it. We'll just tune trees and min-n, or the minimum number of nodes until we get a split in the tree. Random forest classification, we again tune it with the grid, and here's what this particular grid looks like. Let's get it here. Right. Various trees, various min-n's. We again do pre-processing, impute the median, remove that field, because one thing that I forgot to mention is when you skim it or you glimpse it, then I think it's around 70% of this particular field is missing values. So it's really useless, so we're going to remove it. And then we do zero variance on all predictors, the workflow, and here we tune it again. 10-fold cross validation. We once again look at the plot, see what this looks like, and then we see what all these different parameters for the trees look like, for the random forest actually. Alright, and we pick the best one based upon ROC AUC, and we see model 2 at 500 trees with min-n at 2, or split minimum number of nodes at 2. And then we can do some massaging so that we end up with a rock curve. It looks like this. And now we go right into support vector again. We're going to tune cost, RBF sigma, and we're going to pick the RBF model, the radial bias. Seems to be the more popular one. And set the engine to current lab. We will look at our support vector machine grid. So this one has 3 parameters, so a couple more rows, 27 more rows on which the model needs to test. And again, resampling on tenfold cross validation. And this plot looks a little involved, but Tidymodels makes it easy. We can pick the best model based on rock AUC, and we see what the cost is, the sigma level, and the margin, and model number 6. So this is our training. So when we put all this stuff together, well, here's that rock curve for the SVM, but now when we put it all together, now we have this, and it's clearly the random forest on the training. But that's really not what's too interesting. We want to see this on the test model. So on the test, we're pretty much going to go to the same workflow, but this time we have the best model for the logistics, so we're going to pick that one. All right, so here's the logistic regression on the testing data set, and we can see that our logistic tune best was model number 5. So we're going to send that through this workflow here, which is going to see last fit being applied to credit split. Last fit is automatically going to take the test portion of credit split. Right, credit split was 349 at 151, so last fit is going to automatically pick 151 and put logistic tune best model to work. And then when we do that, we do some more massaging, and then we get this right here, which will be the rock for the logistic test, and that's what this looks like. And we do the exact same thing for the random forest, and as you can tell, it's a little bit involved, but Tidymodels workflow, it makes it really easy to do the pre-processing and to change models as well, because we can just change the engine and have a completely different model. So yeah, we're up to 400 lines, not necessarily lines of code, but we're at line 400 already. Okay, so we do the same thing for random forest. All right, random forest tune best, model 02, last fit credit split, and then we end up with this particular rock curve for the random forest test. Same thing with support vector machine. Random forest best one was model 6 at those parameters, and we end up with, well, let's go straight to the comparison, right? And then this is the test of the this is the rock curve of all the tests, of all the test sets. So let me go back to here. So this is for the training, right? And then this one is for the test. Right? So we can already see that training was a clear separation between what's good, but testing, things kind of converge, so to speak, but we still see that random forest is the better model. AUC, at least if we're going to use AUC and accuracy as the metrics, AUC at .79, okay, better than the other two. .775 better than the other two. So we'll use random forest as the model. We're going to finalize the workflow. Right, random forest tune best was the best model, which is then applied to credit split using the function last fit, which again is gonna pull out the test portion of it, just like we did here with last fit earlier on. Once we have final fit, we can use final fit into the prediction portion of our workflow. we extract the workflow on final fit, and then we can then create our object called predict fit, which is the fit prediction workflow onto the testing of credit split. And then now that we have predict fit, we can apply that to our new data, right? We do some rearranging, and then well, when we get done with all of that, we finally get what we're looking for, which is this right here. We have, so this is the, you can see right here, 250 records on that new customers to score data set. We have a customer ID, whether or not they were credit worthy. This has been sorted, I believe, yes. And then probability of credit worthiness and probability of non-credit worthiness. And then we do some more massaging to make it look pretty and all. And then we have, what do we have? This is a new customers plot, so we end up with a plot of how many were actually credit worthy, 208 versus 442. We're also going to bin it because it may be, more beneficial to see it like this, right? Different decile cutoffs. So 208, that's fine, but how is that split up between 50 to 60%, 60 to 70, etc., etc. And then last we have the VIP plot, variable importance plot. The top 10 and then top 5 of those being credit amount, duration of credit month, 8 years, account balance, and then payment status of previous credit, and then our degree of our level of importance. And then last we write that to a CSV file, which could then be shared with others. Yep. So that's it. And also all these files, they should always be in the description for download via GitHub. So yeah, thanks.